if a generator is producing 500 megawatts and 200 megavars, is the generator leading or lagging? So, although this is a straightforward question, and you can practically answer this within 10 seconds, don't be surprised to see very straightforward questions in the PE exam as well. So, don't just be like, okay, it's easy, I'm not going to do it. But sometimes people miss the basic questions. You never know, right? So you have to practice and understand the basics in order to be able to be very good at the more, the more complicated questions. So here, leading or lagging. So first of all, you have to know what are the parameters that actually can help you answer the question of leading or lagging. So for leading, these are your parameters to remember. For instance, so leading, Q is negative, your reactive power is negative, right? Capacitive system, right? And your power factor angle is negative, the angle. So let's say, how do I write that? Power factor angle is negative. So that's for leading. And then lagging, things to remember is reactive power is positive and it's inductive, all right? And your angle, this is angle, and your power factor angle is positive, all right? So just by looking at this problem without even doing any calculation, I can tell, because the reactive power given here is assumed to be positive. I mean, they didn't there's no negative sign in it. I mean, sometimes the negative sign could be included within, but in this case it's safe to assume that this is positive. Everything considered, this is positive. So the system, the generator, is lagging. So the answer would be lagging here. But if you want to be technical, right, and you want to go ahead and calculate the power factor in order to be sure, let's calculate the power factor here. Power factor is equal to, of course, the cosine of theta. But between P, real power, and Q, reactive power, there's a relationship, right? Q over P is equal to tangent of theta. So here in this case we have 200. So we have mega and mega, so they cancel out. There's no need to convert it to vars. Over P is 500. So this is 2 over 5. Right? 0.4. So we can take the inverse tangent of 0.4. So let me use my calculator. And I got 21.8. So theta is equal to 21.8. And my power factor angle is positive in that case, and the power factor is, of course, cosine of that, 0.92. So we calculated the angle is positive, so the generator is also lagging. So you can do it that way as well. So depending, sometimes they give you some keywords in your problem, or sometimes they even ask you, is it inductive or capacitive? And because inductive is associated with lagging system, then you can derive that, or they give you a capacitive system, so you can understand that it's a leading system. So depending on your parameters and what's given, once you understand these and you understand your different parameters associated with leading and your parameters associated with lagging, then you can kind of solve any type of problem associated with a leading or lagging system. So here in this problem, during the exam, you can just look within 2 seconds, realize that this is a lagging system just by looking at the 200 mBars. Because reactive power is positive. But, some people can quickly recognize that, some people don't, and they can go ahead and calculate the power factor, in which case, this is how you calculate the power factor. Power factor angle. All right.